Most modern CSS frameworks are based on some kind of grid, so the idea of a grid system isn't new. The differences between grid systems is often typified by their width, 920, 960, 1140, whether they are fluid, generally percentage-based, resizing as the window resizes, or fixed, widths are set and don't change, and how many columns they use, 12 being a pretty common number. Grid systems have their roots in print design, where designing for a specific number of columns on a page with a uniform gutter width between them and adjusting the width of the content blocks based on some standard norms set for the columns. This adapts really well to the web and has pretty much been in use since we realized that the good old days when everything was 100% width and centered and hosted on GeoCities were really ugly. Bootstrap uses a 12-column, mobile-first, responsive grid system that scales up as the viewport size increases. Like in a spreadsheet, rows can be thought of as the horizontal axis, while columns are the vertical axis. In Bootstrap, rows need to be placed inside of a container class. Inside a container can be a row that is 12 columns wide, and inside that you might put a 6-column block, a 3-column block, another 3-column block. Underneath that you might put another row, and inside that row could be a 9-column block and a 3-column block. The row class is used to break these rows apart. So if you wanted a row to only be a total of 6 columns wide, your next block wouldn't try to sit next to it. Bootstrap uses a series of classes that define the width in columns of the blocks you want to use. These classes are prefixed with col for column, followed by the size of the screen they are optimized for, followed by the number of columns wide, like this: col XS4, column extra small, meaning mobile devices, 4 columns. The available sizes are SM for small screens starting at 768 pixels, MD for medium screens starting at 992 pixels, and LG for large screens starting at 1200 pixels and going up from there. Most of the time, you probably wouldn't use col XS because, for the most part, you'll probably want to be stacking most things for screens smaller than a 768 wide desktop screen. These classes can be mixed and matched within elements, so you could do something like this. In this example, I've got a div that will be 100% width on screens smaller than 768 pixels, after which it will break and take up half the screen, and on very large screens, it will be more of a sidebar. Grid classes apply to viewports and widths that are greater than or equal to the breakpoint sizes. I don't need to say col XS12 for Bootstrap to know to make the div 100% width on small screens. However, if I added column XS9, I'd be modifying this behavior to make the block take up 3/4 of the screen on those devices. Using columns SM6 will apply that 6-column behavior to devices in the small and medium range until we hit the LG breakpoint, which is 1200 pixels. At each breakpoint, the grid sizes are adjusted. Column widths in the XS range are broken up automatically based on the screen size. In the SM range, they're 60 pixels wide, 78 pixels for medium devices, and 95 for large devices. So without a lot of real effort, you could just make a series of col MD classes to create a responsive grid that is stacked until you get to desktop sizes, at which point the columns grow when viewed on large screens. Another way of thinking of the column classes is by device. In this way, you can sort of think of XS being mobile devices, SM being tablets, and MD and LG are desktops. Then you can target your layouts accordingly. Bootstrap comes with a bunch of helper classes too. Consider if you're messing around with layouts and you need to add a clear to force objects into a new row rather than having them float left. You could use the row class, but if this is something that only affects mobile devices, this could break your layout. Instead, you could use something like this. The visible XS class says that this div will only display on mobile devices. The clearFix class adds a clear. When combined, this forces the bottom 2 blocks to display under the top 2. This is handy if, say, the block on the left is bigger than the one on the right. Without the clearfix, the next block would float next to it. But since we've added the clearfix, it will always display underneath, but only for devices that are larger than the XS range. You can also offset columns by using offset classes. Offsetting columns will push objects to the right a specific number of columns. These are structured like regular column classes, prefixed by col, then the viewport size, then offset, and finally the number of columns. Columns can be nested too. In this case, you'd start with a row class. Inside of that, you could put a container of whatever size you want, say col MD9, and inside of that container, you put another row, which will only be as large as the wrapper around it, or 9 columns, and then add your new columns. These columns will be sized relative to the container they are in. So 2 col MD6 columns will only be as large as the col MD9 that is wrapping around them. Want a way to reorder content? That's possible through the push and pull classes. Like offsets, these are structured the same as other column classes, col MD pull and col MD push. Using pushes and pulls, you can swap how objects are ordered and at which viewport ranges this reordering happens.